Okay, hello everyone. I have shared my screens and I hope you can see them. Uh, so I have uploaded the lecture slides and again I have this mistake here. Let me fix it quickly. BK thread concurrency and CPU scheduling. So sorry, I was finishing or giving the final touch to slides until last minute, so maybe there are some mistakes, but I will take care of them and upload the slides again after the lecture. But for time being, I mean, I have uploaded the slides. You can download if you need to follow along. So uh, today, before starting our lecture, I would like to go through the evaluation through the feedback which you have given for my teaching style. So, and then I will try to learn from that feedback and improve my uh, course delivery. So here is this graph which I have generated based on your input, your feedback. So the this graph is basically about the first question, which was asking which one of the teaching elements listed was most beneficial to your learning, right? And here, basically, if for one parameter, for a given parameter, we have a higher value, it's mean that I'm doing good on that, but lower means that I need to improve it, right? So what I see is that most the teaching element which was most beneficial to most of the student was course material, and then maybe instructor support. And if then I compare my evaluation from the last offering of the course, like I just did a comparison here. So if a bar is going down, it's mean that I was not improving. I was actually my performance is going bad or going down as compared to the last offering. So, for example, here, what we see is that more people are saying that okay, course material is getting better, and maybe the part of the reason is that this is my second offering of the course. So definitely, I'm doing a second iteration on the material, making changes to explain the concepts in a bit more detail, or maybe in a better way. Also, students, the other parameter where I saw improvement was instructor support, but the problematic areas are the instructions and grading. So last time, I was also having issues with this parameter or with with this performance uh, s- uh, parameters. So what I did is as what I'm doing differently as compared to the last offering is like last time I was not making explanation videos for the projects, which I am doing this time. And last time, for example, we didn't have the practice exam for midterm one. We had practice exam only for midterm two and final. So I'm trying to do better on that front. I hope I can do even better. Uh, Another issue is the communication skills, and I'm 100% aware of this problem because even before requesting the feedback from you guys, I on the back of my mind, I had this issue that I cannot communicate as well as I was able to do last time. And the part of the reason is that the course is online and it looks like I am talking to a screen, or I'm talking to myself or talking to my slides. And since the student interaction is low, so the communication or the traffic is one way, which then in some way hinders my ability to communicate efficiently, right? Uh, This second graph basically is from the question which was like which one of the following teacher elements listed below need most enhancement to benefit student learning. So here most of the students they were saying that uh, So here in this graph, if some bar has a higher value, then that is a bad thing. Having a lower value is better. So if I compare the graph from fall 2024, so what I see is that many students are saying that they don't feel challenged during this course, which basically mean that uh, it doesn't look like they are learning something new, or it doesn't look like that the course is basically feels like boring.
Oh.
Okay, I hope that laugh is
I took
not
a
for
look at
me.
the.
Can you please mute yourself?
Oh,
Okay. So the other thing was about active learning. So again, this is about active learning and direction between students. Again, the part of the problem is like the course is online, and uh, which does not allow us, which does not give us a lot of opportunities to ask the questions. Like asking, I'm trying to ask the questions, or I'm trying to ask, okay, do you have any question, or do you have any confusion? But again, this is different from when you are in an in-person class. But I will try to address it by including some polls or some active problem solving sessions in each lecture starting from today. Okay, so this is just summary of your descriptive feedback from the survey. I simply gave it your feedback to the Copilot, and it generated me the summary. So again, here this like one thing is like students are expecting is like they should have more interactive exercises, group activities. By the way, one more difference as compared to fall 2024 offering of the course is that this time we are doing the projects in groups. And also the other difference in terms of in domain of projects is like we have broken each project into two modules. So we have like instead of having a big assignment, have broken down into two manageable portions. And I will try to keep those two modules independent of each other as possible, as much as possible. Uh, what else? Yeah, provide clear expectations for exam content. Uh, I don't know if I didn't do that. I think I was clear about the syllabus of the exam. I'm not like challenging you, but that is what I understand. What I think is like I was clear about the syllabus of the exam, and I also tried to convey the format or the difficulty level of the exam by releasing a practice exam and also by releasing a solution for that. Uh, yeah, but we cannot do more practice exam or more questions for the practice exam because we also need to cover the syllabus, right? Uh, yeah, and what else? Offer more detailed feedback on quizzes and assignments. Yeah, that's one way to do that is like maybe we can release solutions for the quizzes, homeworks, assignments, and the lab modules once their due date is passed. So from now on, I will make sure to do that so that students can see, okay, where they had made the mistake. Okay, so with this, let's start with our today's lecture. So today, basically, we are going to talk about thread safety. First, we will talk about thread local storage. We covered this slide last time, but again want to go through it because I remember going through it quickly. So that's why I want to go through the issue of the thread local storage, and then we will talk about thread safety. And with that, we will be done with our thread and synchronization chapter. And then after that, we will move on to CPU scheduling. Okay. So uh, let's start with this example here. Uh, so uh, let's start with the main, right? So what we have in the main body, we have function of the main body. We are saying, okay, create two variables of type thread t because we are going to create two threads and we need to store their IDs. Then we have a variable to store the attributes, default attributes of a thread. We are initializing that variable. by calling the function pthread attribute init, and then we are creating an array of the function pointers, right? So it is an array of type void static, and it has two elements, and both elements, they hold the address of the same function, which is set get my id, this one, right? And then this IDs array, which which we will use to pass as a parameter to the function. Now, if you look at this function set get my ID, what it is doing, it is receiving an a pointer of type integer, right? ID. So we want to use we want to pass these addresses to these variables, or sorry, addresses to these elements of the array when we will call it, when the functions when the threads will be calling these functions set get my ID, right? Now, after that, so we are initializing it as 1 and 2. So the first function, we will pass the value of 1, to the second, we will pass value of 2, ID of 2. And then in the for loop, we are creating the thread. So we are invoking the pthread create method. And here we are, as the first parameter, we are passing the memory location where we want to store the ID of the thread. In the second parameter, we are passing the address of the attribute variable, which we have used to hold the default attributes of a thread in the pthread library. And then in the third parameter, we are passing the address of the function, which we want to be executed by the thread that will be created as a result of this pthread create function invocation. And then the last parameter is the address of the memory location, which we are passing as a parameter to the function that will be invoked by the thread. So basically, the function that will be invoked will be set get my ID. So for the first parameter, we are passing the value of 1 here, because ID is 1, so the value of the first element is 1. And now this, when the second time the iteration will be loop will be iterated, so we'll create another thread, and then its id will also be stored in this tid array, but in the second element, same attribute element is used, attribute variable is used to initialize the attributes of the thread. And then we are passing the second element in the function pointer array, which is actually the name of the same function. So second thread will also be executing the same function, but the parameter which will be passed will be the second element of the IDs array, which is 2, right? And so now when we and that's it. So, and after that, the main function, what it is doing is it is calling, it is again running a loop where it is calling pthread join. So here basically pthread joins mean that wait for those threads which I have created, wait for them to complete. And when you call pthread join, so you need to first pass the ID of the thread for which you want to wait for its completion. Since we want to wait for all the threads, so the parent thread which is creating these threads, it needs to wait for all the threads. So we are passing in a loop. We are calling pthread join again and again with by passing the IDs of all the threads which we have stored in the TID array, right? Okay, so when a thread is created, what will happen? That it will actually start running this code, right? So when you start running this code, let's say when the first thread is created and it is passed the ID parameter of 1 here, right? So it is passed at ID parameter of 1. So my ID will be set equal to the same. Actually, here I'm just passing the address of the first element, this element here, right? So I'm simply storing that address in a local. I'm simply getting the value from that memory location and storing it in my ID. What is my ID? My ID is a global variable, and then I'm saying I'm going to sleep in for one time unit or 1 second, and then I'm saying my print my ID. So if I was passed here the address of first element, so I simply dereference this first element and set it equal to my ID is set equal to one, equal to that value which is one in this case, and then I will print my ID is one, and then the first thread will exit or terminate. Now when the second thread is executed, it will here it will be passed the address of the second element of this array, right? And the second element stores the value of 2. So when it is passed the second address of the second element of the array, internally we are dereferencing it. So when we are saying dereferencing it, we are simply reading the value from that memory location and putting it in the global variable my id. So my id will be equal to 2. Now this thread will also sleep for 1 second, and then it will print my id is 2, right here, and then it will also exit. However, when I run this code, what I see is that my ID is 2, my ID 2. So first thread also prints my ID is 2, and second thread also prints my ID is equal to 2, which is not what I was expecting, right? So the question here is everyone with me until this point? Any questions? No? So the question I have for you is that why both threads have same ID, that is 2. I was expecting that the first thread will print my ID is 2 and the second thread will print my ID is 2. But when I run the code, I see both of them are printing my ID is 2, my ID is 2. Why? So this time, actually, what we are going to do is that I am going to launch a poll. I have created a poll, but I don't know how to enable the individual questions in a poll. So that's why what I'm going to do is that I will launch the poll, and then it will be active for, let's say, 1 minute, and then I will close it. And for the next question, I will launch it again. Okay. So all of you are required to answer the question. So, okay, it is launched there, and now you can, okay, I think it is not launched. Now, yeah, now it is launched, and you need to answer only first question. I will close it after 1 minute. And this poll is not anonymous, which means that the ID of the responders will be recorded.
We just need to answer the first question.
Yeah, only first question.
Okay.
Yeah, because this is next first time that I am doing a poll. Okay, by the way, I'm ending it now. So since this is the first time that I'm creating the poll, so next time I will find a way how to launch individual questions instead of all the questions in a poll. Okay, but for first time, let's like bear with me for the first time. Okay, so the reason for that is like because I think I explained it the last time, but I can explain it again here. Uh, Let me go to
What
one.
are we supposed to do? What are we supposed to do?
Okay, week 8, day 1, right? Just give me 1 minute. Let me plug my drawing board. Okay, so the question is like why both of them are printing my ID is equal to 2, my ID is equal to 2, because here what you see is that my ID is a global variable, right? And both of them are executing this function, right? So if let's say I'm putting here, sorry, my ID, right? And this is global variable, right? So let's say here I have thread 1 and here I have thread 2. I'm just writing T2, right? So let's say my thread 1 starts executing, and when it starts executing the function, it is passed the address of the first element in the IDs array. So the value of the first element is 1, right? And internally, I am simply dereferencing that memory address. I guess all of you knows what is dereferencing. If you don't know, please let me know. What is dereferencing a pointer? Is there anyone who doesn't know what a dereferencing a pointer means?
Isn't that when you free the pointer? You
No,
dereference it?
no, it is not freeing. It is like, okay, let me tell you. Uh,
It's
so
been a while.
Yeah, okay. So it is like, let's say, for example, if in C language, I don't know about Java, but in C or C++, this is what is meant by dereferencing. So let's say you have a variable, or you are writing int x is equal to something 10. So basically, you are saying in memory, create a location, name it as 10, and write a value of 10 at that location, right? Now, if you say int a static pointer, right? And address X. You are saying, okay, in memory, create a location, name it as a pointer, and in that location, store the address of X. Now, let's say the address of X in memory is, I don't know, maybe I'm just making up some address. Let's say 0xF0, right? So here you will have 0xF0, right? Now, when I say that, what does this third statement mean? This third statement mean that go to the address. So remember, pointer itself is an address, right? So go to this address, and putting a star before a pointer means dereference. Dereference mean that go to this memory address and put a value of 10 there. So basically, I'm saying I will go to this pointer, this location, which is named as pointer, but it holds the address, right? So go to
Mhm.
this address. So I am going here, and then at this address, instead of 10, let's say write me the different value so that I can show that it is changing. So
I see,
yeah,
but just go to the address and replace the value.
yeah, that's correct. So here I'm just writing 100. So this statement is known as, this operation is known as pointer dereferencing, right? Right? Okay. So in our example here, we are doing what we are doing is we are doing pointer dereferencing. How? We are dereferencing ID. We are getting the value. I remember ID is what? ID is a pointer. So when I'm saying my ID is equal to static ID, I'm saying give me the value which is stored at the address pointed by ID, right? So what is that value? That value is 1, right? So when first thread is, let's say first thread is executed, so it said my ID is equal to 1, right? So and then it goes to sleep. So I'm just saying here sleep. So when it is sleeping, right? Let's say thread 2 starts executing. When thread 2 starts executing, it gets it also starts execution from here, from last first point. So it gets int static ID, but in this case, what is ID? ID is the address of the second element. So you are dereferencing the second element. So that's why you are saying my ID is equal to 2, right? So when you say my ID is equal to 2, so here you get, sorry, here you get 2, right? And now when you, let's say the thread 2 also goes to sleep right here. So now after that, if thread once comes back and it executes, so it will try to print the value of my ID. But what is value of my ID? 2, right? So it will print 2 here. And when thread 2 wakes up and it also tries to print, it will also print 2, right? Now, the problem here with this code is that both of the threads, they are accessing the global variable or global data here, my ID, but they expect that they will have uh, their own copies of the global data, which is not possible, right? They cannot, two threads cannot have their own copies of the global data. So actually what we wanted each one of them to print their own ID, like my ID is 1 and my ID is 2. But that is not possible because they are storing their IDs in the my ID, which is a global variable, right? So both, like one thread can override the value which is produced by another thread, right? So how can we solve this problem? So we can solve this problem by having thread local storage. What is me what okay, someone is do you point it to now? Uh Giovanni, I don't understand you are referring to which slide. Are you referring to this last slide where I'm saying pthread join? Okay, it was explained. Okay. Okay. So okay, how to ensure that both threads do not share my ID? So we can ensure it by having private copies of my ID for both threads, or having private copies is also known as having thread local storage. Okay. So for example, in C11 variant of C language, so thread local storage is a class specifier, and it allocate and if you use this specifier, so then what happens that you allocate a separate memory location of the variable for each of those threads, right? So when the separate allocation happens when the thread begins and deallocated when the thread ends. Each thread has its own instance of the variable. So here is an example. Everything in this code is same. The only difference is that before int my id, now I am putting this specifier underscore thread underscore local, and yes, I am also including this threads.h header file. Okay. So if I am putting this specifier thread underscore local, if what I'm basically telling to the compiler that my ID could create unique copies of my ID or different copies of my ID, and then each thread uses its own copy. So this time what will happen is that when you will say that, let's say the first thread says my ID is static is equal to static ID. So what will happen is, let me not go back to the one nodes, but just try to show you here. Or maybe I can go back to the, because it is kind of quicker to do the things there. So the difference now happens is here. Remember here my ID was local, but now what happened when you say that my ID is thread local, so thread 1, thread 2, and each one of them have their own my ID. So when this one, the first one sets my ID equal to 1, it sets its own copy, and when thread 2, and then after setting my id equal to 1, thread 1 goes to sleep, thread 2 starts executing, it sets its own copy equal to its own copy of my id equal to 2, and then when thread 1 wakes up and it prints printf my id, it will print 1, and because it will be accessing its own copy here. Remember, now my id is not a global, right? And when this one will do the print statement, it will print 2 because the value of its copy of my ID is 2, right? Both of them have their unique copies, right? And one other thing which is not explained here in the slides is like the or actually it is explained. It's like, for example, here when the thread, let's say thread 1 is setting my id equal to 1 and it goes to sleep, and then it is woken again and it starts executing, it still sees the value of its own id in its own copy of my id. Okay, so question here, I said that if, for example, in C11, we can use this storage class specifier underscore thread underscore local, but what if a language does not support thread local storage, for example, older version of the C language? So then what we can do is that we can use the library support. For example, in pthread library, you have a function pthread underscore key underscore create. You can use this function to create the thread local storage. Okay. How? I'm not going to explain it here, but you can go and check the online documentation of how to do that. Any questions? No? Okay. So now here is another important topic related to programs when you are writing multi-threaded programs. So let's try to first understand this issue through an example. let's suppose you have this program where you have global variables int x is equal to 0, y is equal int x is equal to 1, y is equal to 2, and z is equal to 0. And then you have these two function increment and add and double and multiply, right? So then in the main function, what you are doing is that you are creating the threads, right? So here again, you are going to create two threads. So you create an array of type p thread t to store the IDs of the thread. You have a variable of type p thread attribute. You are initializing that variable with the default parameters of with the default attributes attributes of the structure, and then you are making an array of the function pointer having two elements initialized, first element initialized to increment and add, and second element initialized to double and multiply, right? And then here, before creating any threads, we are saying, okay, print fx is equal to print value of x and y, right? The initial values of x and y. And then we are saying, okay, now create a thread, store its ID in the first element of the ID array, use this default attributes when you are creating the thread, and then first thread is supposed to invoke the first function, which is increment and create, right? And this function receives no input parameters. Thus, in the second iteration, everything is same. The ID of the created thread will be stored in the second element of the ID array. Same default attributes will be used while creating the thread, and but this second thread will call the second function, which is double and multiply this function, right? And this function is also receiving no parameters, so we are passing null as the fourth parameter of the thread. After creating two threads, we are saying, okay, the main thread will wait for both threads to complete, and then it will return 0, right? Now, if I run this thread for the first time, let's say I run this program, what output I expect? Try to run this program on your notebook and tell me what will be the output. What will be printed on the console? Yes, there is no poll. There is no poll, but you need to tell me, like, if you run this program uh, on your notebook, like, what will be the output you will see? Okay, someone has responded. Submission is 5. Okay, product double, like submission is 5 for the first thread, I guess, right? For the second thread, when you run the second thread, what will be printed? So please, students, I cannot make the class interactive, or I cannot ask like, I mean, if I'm asking question and you guys are not responding, then how can we have this two-way communication? So please try to do it on your notebook. Second thread product is 8. Okay. So let's have a look. Okay. So product is 24, 2 times 2, 3 times 2, because use the same global variable, right? Yeah, some other students said that the product will be 24. Okay, let's see how it will happen. So see, x is equal to 1, y is equal to 2. So summation is equal to 5, right? And then product is 24. How the product is becoming 24? Yeah. Uh, so let me do it here quickly, right? So x is equal to 1. So when I say x plus 1, so x plus plus, it's become s is equal to 2. And then when I say y plus plus, so y becomes 3, right? And then I'm saying z is equal to x plus y, it is equal to 5, right? Now when the second thread runs, so it says x is equal to x static 2. So x becomes 4. And y is also doubled, so it becomes 6. And z is product, so 6 times 4 is 24, right? So when I run the program for the first time, I see I see this output: x is equal to 1, y is equal to 2, summation is 5, product is 24. However, when I run the program again, I see x is equal to 1, y is equal to 2, product is 24, summation is 10. How? Do you think it is possible? So,
Right, because they're running in the opposite direction where it's doing product and then summation. Um,
but if it is doing product and then summation, so it should. Can you please elaborate a little bit more?
or I don't have an answer. I'm just trying to piece together why it's happening. And
Oh,
that was the main difference I've noticed, that it's again backwards. We have 24 and 10 starting
yeah.
with product instead of summation, which unless that's an error to which it still makes sense that summation and no, wait. I have no
Okay,
answer.
okay. It is good that you are at least trying, so it's good. So actually, I have a question for this in poll. So I'm launching the poll again. I don't know if I can launch it again or not. Let me see. Relaunch poll. Yeah, I'm relaunching, and you need to do only question 2. Okay. So I have relaunched. Do the question 2 only. No, no, no. There is no question 2.
Yeah, question two is about implementing lock.
Yeah, actually, it was question 1. So, as I said, I'm doing this for the first time, so things are like kind of not synchronized. So, yeah. So here, I don't know if you guys can see the poll on my screen or no, but it says why we have two different outputs for the two runs.
That's the
Yeah,
question that's what's displayed for question 1.
yeah. I mean, this is not synchronized, what I was trying to say. I think the previous state submission is 5 was saved and repeated the same process and added the previous 5 to make it into 10. Okay, yeah. Okay, now let me explain. Let me explain why things are happening like that. Okay, so here is the thing. Let me use a different color this time just to differentiate. So now previously we said that first the first thread completed its execution, then the second thread run and it completed its execution, right? Now let's say that this time what happens that first thread runs this one, x plus plus and y plus plus, and then it is interrupted, right? Which means that it is kicked out. So it is not scheduled. Let's say you have a single core and you can run only one thread at a time. So first the first thread start running and it executed only first two statements, x plus plus and y plus plus. But before it executed z is equal to x plus y, it was kicked out and thread 2 was scheduled for execution. Now when thread 2 is scheduled for execution, it said x is equal to x static 2, so x became 4. It sets y is equal to y static 2, so y becomes 6. Then it sets z is equal to x static y, so z is equal to 24. And then it also printed product is 24. And then the thread was terminated. So the first thread was then after that the first thread was again scheduled for execution. So it again got the turn to execute. So now when it starts running, so it starts running here, z is equal to x plus y. But remember, z, x, and y, all of them are global variables, right? So what is value of x here now? The value of x here is now is
Is now
4.
four.
yeah, that's
It
correct.
should be
Why?
4.
Because both the all remember all the threads of the same process, they share the global variables, right?
Hmm.
Global data. So now for thread 1, the value of x is not 2, it is 4, and the value of y is not 3, it is 6. So
No,
4 plus
6.
6 is 10, so summation is 10, right? So that was the problem. So actually here it was like until at this point it reached thread 1, it was kicked out, and then thread 2 got the chance to run, and once it terminated, then thread 1 was again executed from the same point where it was terminated, and that's why we see different runs for the different output. We see the different output for different runs, right? Okay. So how we can, so this is the problem. Why this is problem? Because we want our programs to be predictable, right? You don't want an application which gives you different result on different runs. Like once, let's say you are running a program, which is a multi-threaded program, and this program is supposed to create a histogram. And let's say it is using 5 different threads to create the histogram. So first time when you run, and the second time you run the program, all the times you want to see the same histogram if the input data is same, right? But if your program is multi-threaded, but it is behaving in a way where it creates different histograms for the same input data on different runs, then it's mean this is crap. You will not use that program, right? So we don't want to have that kind of situation, right? So basically, this behavior where different runs of the multi-threaded program generate different output, it means that our program is not thread safe, right? So a function or a program is thread safe if it produces correct result when called by 2 or more threads, right? So so basically what you want your program is to produce the same behavior or to produce the same result as you were running it as a single threaded program, right? So the result should always be correct. Where doesn't matter whether you have written your program as a single threaded program or a multi-threaded program, right? Being multi-threaded should not affect the accuracy or correction of the result, right? So how can we make a code thread safe? So making thread safe mean that if you run it with 2 or more threads, it will always give you the correct results, right? That is, its effect is the same regardless of the order or interleaving of the execution of threads. So it doesn't matter whether thread 1 executes first or thread 2 executes first, or thread 1 was executed and then it got interrupted and thread 2 start executing, and then thread 2 was in the middle interrupted and thread 1 again start executed, and then thread 2 and so on. So how many combination of interleaving you have, they should not affect correction of your result. So that's mean that if you have this feature, if your program has this feature or characteristic, then you can say that your program is thread safe, right? So how can we make a code or program thread safe? By ensuring that the write access to shared data is exclusive. That is, when a thread modifies the data, it is not accessed by any other reader or writer thread. What is the problem basically here in this program? The problem is that X, Y, and Z, these are global or shared data between two threads, right? So when one of them is like thread 1 is modifying, so what happened that thread 2 interrupted it and it also started modifying the same global data. We cannot allow this. Why? Because if we allow this, then on different runs, depending upon how threads are interleaved, we will have different results, right? So that's why if we want to make our code thread safe, we need to ensure that write access, again, this is important, write access, not read access. We only care about write access because only write access modifies the data. We need to ensure that write access to the shared data is exclusive. That is, when a thread modifies the data, it is not being accessed by any other reader or writer thread. So when one of the thread, let's say you have 10 different threads, if any one of them is modifying the shared data, none of the others should be able to access the data. And these other doesn't matter whether they are accessing for read purpose or write purpose. As the write operation should be exclusive. Exclusive means no one else is accessing the data at that time. How can we do that? By rewriting our program in a different way. And what is that different way? By every time before you access the global data, before accessing that, you get a lock. And once you are done with the access of the global data, you release the lock. So lock X, Y, and Z, and then unlock X, Y, and Z. Similarly, the thread 2, which is running this different function double and multiply, it should also first try to get the lock X, Y, and Z, and once done, it should unlock X, Y, and Z. So locking means if thread 1 locks global data, it's mean no other thread can access that data. uh, uh, all other threads can access the data only when I will unlock that data or I will release that data, right? So if thread 1, for example, now let's try to see if the second when we were running the second time and thread 2 was trying to interrupt, can that situation appear this time or not? So let me again use a different color here, maybe purple. So let's say thread 1 acquired the lock over X, Y, and Z. Now it executes X plus X and Y, these first two statements. Is it possible here for the thread 2 to intervene? No, why not? Because if it wants to intervene, so basically if it needs to, it's mean that if it needs to execute or modify X or Y, it first need to get the lock on X, Y, and Z, right? But the lock has already been attained by the thread 1. Only one thread can get the lock at a time. Okay. So already thread 1 has the lock. So thread 2 cannot get the lock. So it will never be able to run. Even if thread 1 was like intercepted, so thread 2 is not ready to run. So again, the thread 1 will be scheduled and it will continue from the same point. Z is equal to X plus Y, right? So it will see X is equal to 2, Y is equal to 3. So Z is equal to 5. And once it releases the lock, only then thread 2 will be able to get the lock. And again, here in this example, I'm just assuming that it was first thread 1 who was able to get the lock, right? But it is also possible that thread 2 can get the lock first, right? Any questions?
Yeah, I have a question. What exactly in the code is like specifying that that specific thread is locked? So like,
Yeah,
is
here
it the
in this code, we don't have any exact implementation of the lock. I'm just putting it as as a command. Which mean that we need a mechanism to lock these X, Y, and Z. What is that mechanism? We haven't seen it yet. We are going to talk about that in the upcoming slide.
okay?
Yeah. Another question: can the thread intervene but work on another function, hypothetical square root function that doesn't use X, Y, and Z, or will function increment and add need to be completed before going to another thread? I think you are asking that in reference to the previous slide, that if thread 1 is running the function increment and add and then it gets interrupted by another thread 2. So that thread 2, can it run another function? Can you please like unmute yourself and talk? I don't understand what's your question. Giovanni?
Hello, can you hear me?
Yeah, I can hear.
Okay, so like let's say we had increase, so we have the function and then we get that usually that interrupt after y plus plus, right?
Mhm.
So we obviously can't go to double and multiply because the function would be locked, right? Does that make sense? Like after we learn what this lock function is, x, y, and z.
Mhm.
But let's say there was a third function that doesn't use x, y, and z. Could the thread still go to that third function and execute while it's going as long as it's a function that doesn't use the locked global variables? Does that make sense?
Yeah. So, okay. Are you saying like, let's say thread 2 executes a different function which doesn't uses locks, right?
Yeah, correct. Like let's say thread 2 tries to do double and multiply, but realizes that there's a lock, so it moves on to the next function. Was that how that would work? That
Uh,
doesn't.
no. Like, because here what you are doing is that the locks are actually implemented by putting some code. We will see an example, right? So the feature of or the characteristic of lock is like, let's say when the thread 2 it starts executing double and multiply and it tries to get the lock X, Y, and Z. If it is not able to get the lock, it will be stuck there. It cannot continue.
Okay, and then
So
so even if
since it cannot continue, it cannot execute anything else. It will be waiting there until it gets the lock.
oh, okay.
Did I answer?
I have a question as well.
Okay, go ahead.
So is locking equivalent to waiting? Say if add acquires a lock, then if the CPU say switches to double and multiply and it sees that a lock is being used, it will just wait for the lock to be given back, I guess.
Yeah, it is equivalent to waiting, but it is like you can say that implication of failure in getting the lock is that the thread which is failing will wait.
Okay.
Yeah,
Okay,
yeah,
thank you.
but that waiting will be actually uh, stemming from the way how lock is implemented.
So then if double and multiply didn't use X, Y, and Z, it also could not run
No, yeah,
with
but if
threads?
if let's say you have increment and add function and it is not using X, Y, and Z, again, remember we use logs only when threads are sharing the data, right? For example, in this increment and add function, let's say we are this thread one has another variable, let's say A, right? And A is not shared between thread one and thread two. We don't need to put a lock on A.
Yeah, I was just curious to see like even if like if they had data that wasn't being manipulated the same way, that if you could manipulate that data like separate from until you wait for that lock to unlock, if that makes sense. Like let's say this beginning, right, increase and add has XYZ locked. And so it has an interrupt after Y, but let's say there is before X equals X times 2, there's like an A equals 3, if that makes sense.
Okay.
Would it do A equals 3, see that X is locked and go back to 1, or would it just wait until increase and add completely finishes before going to that double and multiply?
Okay, this is the problem of having online class. Okay, let me let me open a new slide. Blank slide. Okay, and I'm just copying this code here. Okay, now tell me where you want me to make the change.
So right on top on double and multiply.
Mm-hmm.
On top of X equals X times 2, do A equals 3, for example.
Before the lock or after the lock?
Before
Okay, A is equal to?
3, right?
Okay.
Or 2 times whatever, yeah, right? And
Okay,
so
okay.
let's say we start at increase and add, right? But
Yeah.
there's an interrupt after Y plus plus.
Okay. Yeah, continue then. What's
And
your
so
question?
after there's an interrupt,
Yeah.
and it goes to double and multiply, will it still execute A equals 3, but once it goes to X equals X, it goes back, it waits until increase and add finishes?
So A equal to 3, since it is not protected by lock, right?
Yeah.
So it will be executed. But
Okay.
X is equal to X static 2 will not be execute because lock is not available because thread 1 has already locked X, Y, and Z.
Yeah. And so if you were to put the A equals 3 after that second lock, does that change it as well?
You mean if I
Or
put
no?
it here,
Correct.
A is equal to A, let's say A times 3, I don't know, right?
Yeah, but because the lock above it has X, Y, and Z, will it not go there, or will it still find that A first?
No, it will not be executed. Why it will not be executed? Because here we are saying everything between lock and unlock statement is protected by lock. So
Correct. But since there's a current,
although here in comment I'm saying X, Y, and Z, but when you say lock and unlock, anything in between is protected. So protected means you first need to get the lock. So
yeah,
the lock is already acquired by thread 1. So A is equal to A
yeah,
static 3 will not execute.
because we haven't received the
No.
original unlock before you can lock it again,
Yeah.
right? Okay,
Yeah.
fine, that makes sense.
So are we locking variables or are we locking instructions?
Actually, we are locking the code.
Okay.
Yeah.
Okay. Yeah, makes sense. Thank you.
Okay. Okay, so the question is like here you were asking that, okay, we have this, sorry. So here we have this command to just to indicate that we first need to get the lock and then release the lock, but how we actually do it. So there is like, let's try to see how we can do it actually. So we can do it by writing functions for getting the lock and releasing the lock, or unlocking and unlocking, right? So for example, our lock function can look like something like this. Let's say you have a global variable lock var, right, which is shared among all threads. Let's say in our example we have only 2 threads, so both of them can access lock var, right? So now keep in mind the previous example where I put the command lock x, y, and z and unlock. So wherever you are saying lock, so there you can call this function lock, int asterisk lock var. So what you are saying is like here you are checking the value of 1. So you are dereferencing the variable. If the value is equal to 1, if the value of that variable is 1, it's mean that someone has already got the lock. So the lock is not available. So if lock is not available, just keep waiting in this infinite while loop, right? And let's say the other thread. So the other thread, let's say it has received the lock. It has already acquired the lock. So that's why the value of lock var was 1, because the other thread has set it equal to 1. Now we will wait for the other thread, let's say thread B, to release it. So when thread B will be done, it will call unlock. So when it will say unlock, it will call unlock. What it will do, it will set the value of lock var equal to 0. Now remember, our thread A, or the first thread, is in the while loop, continuously checking. So as soon as second thread sets lock var equal to 0, this condition will become false for the first thread A, and it will continue and it will set lock var equal to 1. So basically it acquires the lock, right? Are you on with me on this or not?
Yeah.
If not, please let me know, okay? So now let's have a look at assembly of this code, right? So this is our C language code for lock, and here at the bottom we have the assembly, right? So when you look at the assembly, what are you doing? You are basically saying load the value of lock var memory location into register R1, and if it is not equal to 0, if our value of R1 is not equal to 0, which basically mean if it is 1, so other than 0, so go back to the loop lock, right? You have taken the course on assembly language, right? So it is a little bit different from that, but it is assembly language. So, and then once you get out of the loop, you are doing what? You are saying set the value of lock var equal to 1 and then return. So this is assembly version of lock function. And what is the uh, assembly function of the unlock version? It is unlock function. It is straightforward. You are saying just set the value of lock variable equal to 0 and then return, right? So if I say that this implementation will of the locking and unlocking will not work, like the will not work mean like it will not allow what we are trying to achieve by having by calling the function of lock and unlock. We are trying to achieve that if one thread is accessing the global variable, for example in our case x, y, and z, then other thread should not be allowed them at the same time until the thread 1 is done with its access of x, y, and z and has released the lock, right? So we are saying what we can do is that before accessing x, y, and z, I can say, okay, lock variable, and then access x, y, and z as thread 1, and then call unlock. And then on the other side, thread B can also do the same thing. It can call lock variable before accessing x, y, and z, and once done it can call unlock, right? Just to make things clear. So basically what I'm saying is that here in this code, we will simply replace this one with function lock variable, and this one with unlock function. And again, this one with lock function and this one with unlock function, right? Everyone with me?
So we lock it so that way it doesn't bleed over into the other process.
Yeah. So our intention is to achieve that behavior, right? So I have explained you how this code is working both in assembly and C. But after explaining, if I say that even if in my example I call these functions, I will still not able to prevent thread B from interrupting thread A. If I make that statement and I ask you why, well, what will be your answer? So
Is it
basically, what
because
I'm saying is that what is wrong with this implementation of locking and unlocking?
is it because at the beginning of your function you can just put unlock and then
Okay,
it'll
okay. Here I
function?
have again, I have a poll and I want most of the people, like all people to participate. So let me again relaunch poll and let me tell you which question you need to do. You need to do question 2. Please, I want everyone to participate. Only couple of people are participating in the post. That's not a good thing.
I don't believe it's letting me submit. I don't know if anybody else is having the same issue.
Yeah,
Uh,
for some reason, it does not let you submit as long as question 1 from the poll is answered.
okay, it's fine. I mean, for time now, I just want you to interact, right? It's not graded, right? So, but next time I will take care of these like logistic issues, how to launch individual questions and how to allow submission. But for time being, I just want you to like participate. Okay. Okay. Did not let me submit until okay. That's fine. Okay. Okay. Now the problem is like okay mm, one person corrected it answered it correctly. So the problem is like the problem is that this code is not atomic. What do you mean by not atomic, right? Not atomic mean, now let's say, let me try to do this. Okay, going back to OneNote. Okay. Remember what we wanted to do? We wanted to say that, okay, here again I have thread 1 and here I have thread 2. And let's say I called an lock, like lock var 1, whatever its name was, doesn't matter, right? And then here I had access Y and Z, and here I was saying unlock var 1. And for T2, I also had same lock and var 1, and then access X, Y, and Z, and unlock, right? Now let's say T1 executes this function L1, lock var 1, right? Now let's go to the assembly of that function. So what is happening here? If you look at the assembly, so in assembly you are saying, okay, okay, maybe I can. Yeah. So what is happening in assembly? You are saying put value of lock var in R1 and set uh, and keep locking, keep checking it as long if it is not equal to 0, right? But the problem is like when the thread one is, let's say, at this point, right? Thread 1 is executing the lock function, and it at this point, it can get interrupted, right? Which means it can get kicked out from the CPU core. It is not running anymore, right? So if it is not running anymore, what is the value of the lock var at this time, right? Uh, so let's say that initial value of lock var was let's say that the initial value of lock var was equal to 0. Lock variable is equal to 0, right? And now thread 1 executes lock. So it says load the value of lock var into R1. So R1 is equal to 0. It says if R1 is not equal to 0, go back to the lock, but it is not, right? So it is not. So for it, the value of R1 is equal to 0. But before it can start executing the next instruction, the instruction number 3, right? It gets interrupted, which means it is kicked out of the core and the thread 2 starts executing. Let's say now thread 2 also invokes the lock. Now thread 2 also will load the value of R1 into value of lock variable in R1, which is equal to 0, right? And after loading it, let's say it continues executing the third statement. So it says, okay, lock variable set lock variable equal to 1, right? So which is like it is setting lock variable equal to 1. So basically it is assuming, thread 2 is assuming that I'm getting the lock, right? Is everyone with me until this point?
I see. So
I hope
the
I'm
second
not
one locks, but the first one hasn't locked yet, and you can't have two locked at the same time.
Yeah, the second one has locked, but the first one was kicked out, right? So let's say after the second one has locked, received the lock, the second one is allowed to execute again, right? It is scheduled again for execution. So it will start execution from the same point where it was interrupted, right? So if it starts execution from the same point, so it will execute the third statement, which is like setting the lock variable equal to 1. So actually it is not in loop anymore, right? So what is happening here? Both of the threads are getting the lock at the same time, which is not the behavior we want. The behavior we want is like only one thread can acquire the lock at a given time, right? Is everyone with me on this? If not, please let me know. No problem? Okay. Okay, so why it is happening so? It is happening so because you are testing the value of lock in this statement. In statement 2, the code is testing the value of the lock in this statement and setting the value of lock in a different statement. So between like there are two steps: testing the value, which you are doing in the second statement, and setting the value, which is the third statement, right? But it is possible that in between, while thread 1 is done with testing and before it is able to set, and it is kicked out, and another thread comes in and it is able to set the lock. And when the thread 1 comes back, it also gets the lock, right? How to avoid the problem? By making testing and setting of the lock variable atomic. Atomic mean like it is a single operation. It is not possible for a thread to be kicked out at a point where it has yet only tested the lock but has not yet set the value of the lock, right? So if we can get that kind of an instruction that does the two things in as a single instruction, like testing the value and setting the value, then thread 2 will never be able to get a lock if only one thread will be able to get a lock at a given time, right? So for example, if thread 1 here tests the locks and finds that okay, it is 0, and then it sets the lock, and these two statements are single statements. So it's mean that thread 2 cannot do this thing, right? Thread 2 can only read the lock, but it will not able to like test and set it because thread 1 is setting it. It's not possible, right? So that is the problem here with this implementation of the lock. So thread B, it can intervene before thread A stores 1 to lock variable, resulting in a race condition. Let me delete these annotations so that I can read it. So thread B can intervene before thread A stores one to lock variable, resulting in a race condition. This lets more than one threads to get the lock at the same time. Yeah. Yeah, I mean, yeah, let's stop here, because if I go to the next yeah, let me complete the next slide, because it is essentially the same thing. So why naive implementation is incorrect, which we have seen in the previous slide, because it is possible, as I said, that thread B can intervene and set the lock variable equal to 1 before thread A sets it to equal to 1. And when thread A will come back, it will again, it will assume that I have also acquired the lock, and both will enter, both will start accessing their shared global variables, which is not what we want. So it means that we need an atomic instruction, just as I explained. It is an atomic sequence of load, modify, and store. Here, basically, what is happening is that we are having three different instructions. Like this first instruction is loading the value, second one is testing the value, and third one is checking, setting the value, as a three separate instructions. And in between, it is possible that a thread which is executing this set of instruction, it can get interrupted. However, if we have a single instruction which does all these three things, which is load the value, check the value, set the value. So if we have a single instruction, and it means it cannot be interrupted, then we will be able to achieve the locking behavior, what we want, right? So only one atomic instruction from any processor can be executed at any given time, right? So if this block is a single instruction, then we will be successful in implementing the locking, right? Okay. Yeah, so let's stop here, because from the next slide we are starting a new topic, which is like Peterson algorithm. We will talk about next time. Yeah, okay. If you have any questions, please let me know now, before we conclude our today's lecture.
Can we look at the thread safety slide for question 1?
Thread safety slide.
Yeah, where you were talking about that Z gets kicked out of, so like when you run the code twice, that Z gets kicked out. I don't necessarily understand that.
Are you talking about this one?
Yes, yes.
So yeah, now tell me the question.
So when we go to, so run 1, like for me is pretty straightforward, but for run 2, you say that Z gets kicked out for
Mhm.
increment and add.
Mm-hmm.
I'm not exactly sure why Z is getting kicked out.
Okay. Okay, I can explain. Just give me a minute. So why is he getting kicked out? So our basic assumption is, like, we have only one core in the system, right? You have only core A, let's say one core. So only one thread can run on a core at a time, thread 1 or thread 2, right?
Right,
Let's say first thread 1 is running, right? So it sets x is equal to x plus plus, so it becomes 2. It sets y equal to y plus plus, so y becomes 3, right?
right,
And then before it executes this next line, before it executes z is equal to x plus y, what happens is that, let's say, uh, our scheduler, it gives, let's say, 10 time units to every thread, 10 seconds, let's say. And at that time, the 10 seconds for thread 1 are expired, right?
right.
And then thread 2 is ready to run. So now thread 2 starts running on this core.
Okay. So by the time it gets to Z, the thread 1 is terminated,
Yeah,
essentially.
because this time budget was expired. Let's say the time budget which was allocated for so we are saying T1 was allowed to run at most for 10 seconds. So by the
Right,
time it reached at this time point, its time budget was expired. It doesn't have any more time left, so it must leave the core.
Okay.
Yeah. So that has
Thank you.
something to do with scheduling, right? So that was the assumption which I think I should have explained right before, like before starting the example. Any more questions? No? Okay, then if no questions, then that's all for today. See you on Thursday.
Thank you.
You're welcome. Thank you.